This UCSD TV program is presented by University of California Television. Like what you learn? Help others discover UCTV podcasts by leaving a comment or rating for us in iTunes. Also, make sure to check out and subscribe to our YouTube original channel, UCTV Prime, available only on YouTube. This UCTV podcast is sponsored in part by Audible.com, your destination for the widest selection of digital audiobooks available, including many by guests you've seen on UCTV. Audible.com is offering UCTV viewers a free 30-day trial subscription and one free audiobook download. Just visit audibletrial.com/UCTV to sign up, and thanks.
Good evening. My name is Cheryl Peach. I'm a program scientist here at the Birch Aquarium at Scripps and the director of Scripps Educational Alliances. Welcome to the Jeffrey B. Graham Perspectives on Ocean Science lecture series. It's my great pleasure this evening to introduce our speakers, two scientists from the NOAA Southwest Fisheries Science Center, Drs. David Weller and Wayne Perriman. Both are in the Protected Resources Division at the Southwest Fisheries Center, and Dave specializes in the biology and ecology of marine mammals. His work is actually focused on behavioral ecology, population assessment, and importantly, the evaluation of potential disturbances of impacts from human activities. He currently directs two programs, one on the endangered population of western Pacific gray whales off Far East Russia, and one on coastal bottlenose dolphins right here off the coast of California. Wayne Perriman's expertise is in the development of aerial photographic techniques that will allow researchers to accurately count and assess the number of marine mammals in large aggregations and to determine the size and shape of individuals. He's integrally involved in a number of programs that are monitoring the reproduction of California gray whales based on this type of survey data. So I'm sure you're going to hear a lot more about both of those topics from first Dr. Perriman and then Dr. Weller. And I want to thank you very much for being here and being part of this series. Join me in welcoming first Dr. Perriman as he introduces the talk, Gray Whales in a Changing Environment.
Thank you very much. Thank you all for coming here. So Dave and I are going to do a little tag team on you here. I'm going to go first and talk primarily about the eastern population of gray whales. He's going to follow up and talk about another group of animals. And we're going to focus on what's changing, what's happening to these populations of large animals as the environment changes. So probably just as good a title could have been, what we know and what we thought we knew. Because as the environment changes, what we thought we knew about these animals turns out maybe not to be quite so correct. So we're going to take kind of a geographical approach to this. Dave is going to talk about the animals that are found off the coast of Russia, the western Pacific population of gray whales. And I'm going to talk about the animals we're all most familiar with, the eastern North Pacific population of gray whales. This used to be a very simple introduction. It's gotten more and more complex. In both environments, things are happening, and we're learning that our original ideas of how these animals are separated geographically may not be true. In addition, within the eastern North Pacific population of gray whales, we used to be able to just say that gray whales went up to the Chukchi Sea and fed and migrated all the way down to the lagoons and back again. Well, it turns out that's really not true for the entire population. There's a group of animals that really never make it back to Alaska. And those animals are feeding from about the northern border, the Oregon-Washington border, up through British Columbia. I'm not going to talk about those animals very much. I'm going to talk about the bulk of the population that does the traditional migration from Alaska down to Baja. So what I want to do, I want to start off and talk a little bit about the history of this population. Let's get some background on what's happened to them. I'll talk about exploitation, protection, and recovery. Then I want to talk about the basic biology of gray whales and how you collect those kinds of data. I want to expose you to the fact that, trying to do research on an animal that doesn't get out of the water and that's really big is not that easy. So how do you study an animal if you can't get any? I want to talk about the monitoring efforts that we do at the Southwest Fisheries Science Center. We're monitoring abundance of these animals. We're trying to estimate reproductive rate. And we're also looking at condition. How robust are the individual animals within the population? I want to talk a little bit about climate change. I know some of you don't mention it, but you've got that Rush Limbaugh button on your AM dial. So we're going to talk about climate change, and maybe we can straighten you out about good old Rush. I also want to talk about recovery. When populations recover, things happen that we didn't expect. So I want to talk a little bit about the consequences of recovery for a population of large animals. So let's get into the history. There were centuries of takes of gray whales along the coast by native people, certainly taking tens of animals every year. But in the mid-1800s, the Yankee whalers found the lagoons, and that's when the carnage really started. They could go into the lagoons with their large ships, kill thousands of animals, and they were focusing on the biggest animals in the population, the most robust, so they're taking lots and lots of females. And that caused the population to crash. In the mid-1800s, also a lot of people came to the West Coast, and there were people that came out here to be miners but weren't successful at that, and they went back to doing the things that they'd done previously. So there were coastal whaling stations that sprung up all along the coast. They needed whale oil for the lamps in the mines, so this was a very big operation, certainly taking hundreds of gray whales. There was a period of modern whaling along the coast in the 1920s, stretching into the 1930s, where we had factory ships offshore taking gray whales. This stopped in 1937 when the U.S. protected the population, and they received international protection in 1946. There still is whaling on gray whales that's conducted by Russian native people off the Chukotka Peninsula, and they take about 125 gray whales a year under a permit from the International Whaling Commission. There was another period of whaling on gray whales that took place in the 1960s, and this was scientific whaling that was conducted under a special permit to the Bureau of Commercial Fisheries. That's the agency that was the predecessor to the National Marine Fisheries Service, which is the group that I work for now. And they were given permission to take 316 gray whales. The reason they did this is whaling nations had noticed that gray whales are recovering, and there was starting to be pressure to start again whaling on these animals. We wanted to at least get an idea of what the status of the population was before we allowed whaling to start up again. This was a very systematic effort conducted by the Del Monte and Golden Gate fishing companies of Richmond, California. And they sampled both the southbound and northbound migration, focusing on animals that they could take right off of San Francisco Bay. It was from this period of scientific whaling that we really learned the basics that we know about gray whales. For instance, we know gray whales mature at an age of about 8 years old. Females can reach, or adults can reach about 15 meters in length or 50 feet, and they weigh about 40 tons. Peak calving date is around the middle of January. It looks like it's still about that time period. Gray whale calf is about 4.6 meters long when it's born. A healthy female can calve every other year, but it looks like the animals in this population now are calving about every third year. Calves remain with their mothers until mid-August. They're weaned up on the feeding grounds in Alaska. The migration from the Chukchi Sea to Baja takes about 2 months one way. So these animals are going to swim for 2 months down here, hang out at Club Med off of Baja, and then swim back. And they don't feed much during this time period, very, very little. So they're fasting through almost all of this, and that's important, and I'm going to get back to that. In the southbound migration, there's some segregation based on sex and reproductive condition. The southbound migration is one continuous pulse of animals, but it's led by pregnant females that are just about to give birth. That's followed by a group of adult males and females, and juvenile animals kind of bring up the rear. The northbound migration is different. It's in 2 distinct pulses. The first wave to go north are the females that have just gotten pregnant. So they've been fasting now for about 4 months. They're really lean. They've got to get back up north and fill their tanks up. They're followed by a mix of adult males and females, and again, juveniles are the rear of that first pulse, and that pulse is followed by a separate pulse that's almost exclusively cows with calves. It's hard to do research on large whales. It's not like working on deer or moose. If you have kids that want to be biologists, for heaven's sakes, have them work on something that has hair. It makes it a lot easier to attach something to them. Typically there's a take so you can get some animals. But with large cetaceans, it's very difficult to get specimens to work on. Also, every specimen represents just a gold mine of data. So you can see Francis here perched on the top of this blue whale trying to get inside of this great big animal. Logistically, it's a very difficult thing to do. But whenever a dead animal comes ashore, they're covered with scientists. They just swarm all over them, trying to get as much information as they can, because each one is a rare event and very, very valuable. I avoid it as much as I can. It is totally disgusting. Here you see Frances. Look, she's been in gore all the way up to her waist. You know, it's too bad this isn't like a scratch and sniff screen, so you get a feeling for this. But the best clue as to how bad this is, all these people that are watching, you notice how far back they're standing? It's because this is just terrible. I want to move on and talk about the research efforts on gray whales that we do at the Southwest Fisheries Science Center within the Protected Resources Division. And I want to talk briefly about estimating abundance of gray whales, talk about how we monitor reproduction and how that might be tied to things that are happening in the environment. I want to talk a little bit about population condition and how you collect those kinds of data. And then I want to talk a little bit about predators. As a population increases, as the prey increases, the predator populations do well, and they increase also. Then I'm going to talk a little bit about what's happening in the coastal environment as whales and ships become more plentiful. And I'm going to skip over population structure and let Dave talk about that aspect of whale biology. So the way we estimate groups, or estimate the size of the gray whale population, is we simply count them from shore. They're coastal migrators. The shelf is especially narrow just south of Carmel, California, and we've been counting gray whales as they pass a research station about 7 miles south of Carmel along the Central California coast. We've been doing this from the same site in almost the same way since 1968. We stand watch 9 hours a day, 6 days a week. And the current abundance for this population is thought to be just about 20,000 animals, and it seems to be relatively stable. Just as a note, the eastern North Pacific population of gray whales may be the only population of large whales that's completely recovered from exploitation by commercial whaling. So there are probably as many gray whales right now as there were back in the 1800s when whaling started. The way we count the whales is we have a team of observers in a trailer working together. One observer is looking out with binoculars, spotting groups of animals. That person is helped by the other observer. And then the second observer, the one here by the computer, her primary job is logging the data as the other person sights whales, estimates how many animals there are, and tracks them as they go by. We have a computer system that allows us to enter data on where we saw the whales, and it'll predict where the next surfacing will be for that group. So it really helps us when we've got 10 or 12 groups of whales going by, trying to keep them straight. In spite of that, we really don't do that good a job counting animals. It's very, very difficult. There's a lot of variance associated with individuals and their ability to detect animals. So we're looking for another way to do this business, and one of the things we're thinking about is using thermal sensors. These are a couple of instruments that we got from the Navy. They're antiques by military standards, but they're far better than anything we could ever afford to buy. And what we're doing is taking advantage of the fact that a gray whale is a great big animal. It sucks in a breath, a lung full of air. It holds that breath inside, and when it blows it out, it's much warmer than the background. And I want to show you what that looks like here. You'll see a group of whales coming in this area on the frame. It is just about 2 in the morning, so it's pitch black outside, and the breath of these whales jumps out just clear as a bell. So this system is working very well, and we're using it right now to monitor day and night migration rates, which aren't actually the same. The way we do this is we have some poor unsuspecting person like Stephanie over here do this for hours and hours and hours and write this stuff down, and she's finally stopped doing it, and she's off medication, and she's doing just fine. But, you know, it's not a very good way to make a living, and we don't even pay her. So anyway, that's what this looks like. We're moving into a new phase where we're having computers do this. We can have a computer scan this because this is something computers are really good at. And I think the future of this may be that we'll do this almost entirely with thermal sensors. We don't have to pay them overtime. It works just as well in daylight as at night, so we can do it 24 hours a day. So it's a very effective system. That's enough. I can't even stand that anymore. We count gray whales as they migrate northbound as they pass the Piedras Blancas light station, which is a beautiful little point of land up near San Simeon, very close to Hearst Castle. We started doing this in 1994. That's when we took the eastern North Pacific population off the endangered species list. Right at the same time, there was some data from the Russian fishery indicating that pregnancy rates were going down. So we're very concerned that maybe here we are taking them off the endangered species list just when reproduction is crashing in the population. So we started counting animals there in '94, and now we have a wonderful data set. This is a very valuable time series. If you're going to ask questions about climate and how it's affecting populations, you can only do that if you have long time series, and I'm going to get back to that. So this is just an example of how close these animals pass to shore. You can see a gray whale cow and a calf here. You could hit them with a potato as they go by. They're so close to the beach. We think that the inshore corridor probably reduces the probability that killer whales can find these animals as they migrate northbound. So they're probably hiding in the noise that's made by all the animals that live inshore. And also, when you see killer whales attacked by gray whales, one of the first things that gray whales will do is run to shallow water. And I think that's probably because when killer whales are attacking large whales, they try to come up underneath of them. And so when they get into shallow water, a lot of times the killer whales will just give up and find some more gray whales somewhere else. Okay, I'm going to jump to the results of the time series. So these are estimates of the total number of northbound gray whale calves starting in 1994, and I've got data here up through 2011. So in 1994, we estimated there were just about 945 northbound gray whale calves, and the bars around the dots are just an indication of our uncertainty about exactly where that dot happens to be. Now, we expected this to be kind of a flat line. We thought reproduction would be pretty constant across time on these, and we were absolutely wrong. As you can see, there's a tremendous amount of variability in calf production in this population. And we really didn't expect that, and at first we had no idea what was driving this. So what we did is started looking at environmental data, and one of the things we zeroed in on was the amount of ice up here in their feeding grounds in the Bering and Chukchi Seas. And these are two data series over the same time, the top one being ice covered just in the month of May, and the bottom one being our calf data. And it doesn't take a lot of fancy math to see that when this is low, this seems to be high. And when this is high, this seems to be low. So we think that there's something going on in the relationship between the distribution of ice and success of reproduction in gray whales. So we thought about this, and we kind of worked through this reasoning. It took me a couple of years to do this, but we'll do it in about 30 seconds. So we know that females become pregnant as they migrate southbound or off the coast of Baja. We know that newly pregnant females are the first gray whales to return to the feeding grounds, and they're also the first to depart heading back south. We know gray whales don't feed significantly during their migration, and we know that gray whale females, the reproductive females, will fast during the first and last 2 months of their pregnancies and through 4 months of lactation. And fasting and lactating is a big deal. They're just pouring out energy. So if you're going to be successful at reproduction and you're a female gray whale, you've got to be a pretty robust female. So we put together this hypothesis. We said, we think that in heavy ice years, ice limits access to prey for pregnant females and reduces the probability that those existing pregnancies will be taken to term. And just to illustrate what we were thinking about, this is an example of the distribution of ice in May in 2010. And here come the gray whales, and they come, swimming up. And a female can get quite a ways north in May in 2010, and it was followed by a relatively high year in reproduction. Okay, this is the ice extent in May of 2012. 2012 had the greatest extent of seasonal ice in the Bering Sea ever recorded. So at the same time, this is what gray whale females are running into. They can't get anywhere near the feeding grounds. They're being stopped by this big block of ice. So And I'm predicting next year will be a very low reproduction year for gray whales. So anyway, we wrote a paper about this and we sent it off to the International Whaling Commission thinking that they were going to tell us what a bunch of bright guys we were. And actually we got into a tremendous argument with a group of scientists whom we call the ovulators, because they really feel that the link between female reproduction and her health is through control of ovulation. And that was just one of those things that everybody knew. And so they felt very strongly about it. And what we were saying is, we don't think that's the case. We think these females get pregnant. It doesn't cost anything to get pregnant. But if they get up and they can't get enough to eat, we think those pregnancies probably don't go all the way to term. Well, the ovulators didn't like that. They said terminating pregnancies would be dangerous to the mother. But what we said is the danger is greatest late in pregnancy, and we think it happens very early. What's more, remember, these females are fasting, so that fetus isn't growing very much at all. So they came back and said, Rice and Woolman, they're the ones that did the whaling study in the 1960s, they said the control is through control of ovulation. Well, we said, yeah, they did say that, but they didn't have any data to support it. It was just an idea they had. And all the current data really supports our position that the link between a female's condition and a reproductive output is through control of existing pregnancies. Well, they really got frustrated with us and they said, well, you shouldn't let models run biology. And actually, we didn't know what that meant for a while, but what they were saying to us is our model was too darn simple. We should have some life history in the model, and that's what we're working on now. We're trying to build a much more sophisticated model that will allow us not only to do a better job fitting the data we have, but also tell us more about gray whales. So something's happening here. We got a link between an environmental event and reproduction in gray whales that seems to have been going on now for about 20 years. So is this climate or is this weather? And that's a real important thing, and I bring it up because not only does Rush get it wrong, but scientists get it wrong too. You see papers published with 3 years of data, and they call it a climate effect. Well, really what they're talking about generally is weather. And so this is my favorite kind of data because I just made it up. So say you're monitoring something like the amount of ice-free area in the Chukchi Sea, and you've been doing it for 40 years, and you fit a model to the data, and you get this really nice linear relationship. This is a nice climate model. It's a long time series. You see a kind of a steady change over time. So that looks really neat and tidy. Unfortunately, this is what weather looks like. It bounces all over the place. It's very difficult to do climate science because weather is so highly variable. And also, say someone comes here to Scripps to get a PhD and they start here, well, the trend in their data is just exactly the opposite to really what's happening in the long term in the environment. This is a mistake that a lot of us make. I'm going to show you one more graph and you have to bear with me. In addition to the fact that weather is very, very noisy, climate trends are not synchronous across seasons. So what happens in the springtime may not be the same thing that you would see in the summertime. And these data illustrate that. These are just data that represent total ice cover in the Arctic starting back in 1979 and going up to about 2010. And we got two data sets, one from September when ice reaches its minimum, and those are the red squares, and their relationship is represented by this line. That's a nice negative trend that shows that we have less and less ice in the summertime. The black dots represent ice in March when ice is at its greatest extent. And what you see here is the relationship is very different between these two seasons. And I think this is the key to what we're seeing in gray whales. I think that this increasing difference between summer ice and the winter ice the gray whales face as soon as they migrate northbound is the key to the climate effect on this population. So if you went back in time about 20 years and you went here to the Chirikov Basin, this used to be gray whale heaven. There would be thousands of gray whales feeding shoulder to shoulder right there in the Chirikov Basin. You go there now and you hardly see any gray whales at all. They're feeding way up here, much, much farther north. So I think as ice has been reduced in the summertime through climate change, the feeding environment for gray whales has shifted farther and farther to the north. But access to the north has not changed as rapidly as the shift in feeding grounds. And so these females are hitting ice way down here and they can't get up there to feed. So I think that's what's driving that system. So I'll get off my soapbox because it's my favorite thing. So the next question we ask is, okay, we know gray whales are feeding in different places, but how is it affecting overall population? Is there a population effect? And again, you can't go out and whack a bunch of whales, so you have to figure out a way to ask those kinds of questions remotely. And what we do is we do aerial photography. We collect images with high-resolution digital cameras, and we collect these digital vertical images that allow us to measure these animals very, very accurately. Whales are just like all of us. If they eat a lot, their shape changes. And so we can monitor those changes in shape, and we can tell how robust or how fat the population is. If you're a gray whale, you only get to feed half the year, so being fat is pretty good. We all understand that there are changes in shape in mammals related to reproduction. So reproductive females have predictable changes in their shape. Here Gabby is just about 3 or 4 days from having her baby, and Claire just had hers about 3 days ago. And so they're nice, robust, reproductive females. So these are examples of changes in shape associated with reproduction in mammals. Now, because female humans feed through this whole reproductive event, really their changes in shape are not as dramatic as what we see in large cetaceans. And that's because large cetaceans are what we call capital breeders. So they go up to their feeding grounds and they eat like crazy and get just as fat as they can because they've got to draw on that fat to get through the end of gestation and then feed their babies before they migrate back north. So what we've been doing in our studies is looking at these changes of shape that represent reproduction in these animals, monitoring the number of southbound pregnant females, and looking to see how robust they are. And here's an example of what they look like. This is a southbound gray whale that's nice and healthy and big, but this is a southbound pregnant female. And you can see she's really wide, all the way from here, all the way back here. She's a nice, big, healthy, heavy gray whale. And this is something we've been monitoring over time to look for patterns and change in the robustness of gray whales as they migrate. I'm going to move on to predation because as protected populations recover, their predator populations respond to that. And we're seeing more and more of this kind of an event in gray whales as they migrate northbound. One of the ways we're investigating this is John Durbin and Bob Pittman, who's back here, have been putting tags on killer whales up in the Bering Sea. We know that they wait for the gray whale cows and calves to go through Unimak Pass into the Bering Sea, and they jump them there, and they take a lot of calves as they migrate through. So they put these little tiny tags on the dorsal fins of killer whales just to monitor how long did this predation effort take place. So they did this in May, and they got pretty much what they suspected. Now this is through several Mays, so this is several years of data, and all these little red dots are just fixes where the killer whales were. And all through May, they stayed right in the same place. As the cows and calves are streaming through, they were just there jumping them and taking them in pretty good numbers. We thought that once that was over, that they just shifted and went back to eating harbor seals or something else. But some of these tags lasted longer than we expected them to, and look what happened. These killer whales, instead of moving on to something else, stayed with the gray whales and followed them up to the feeding grounds and continued. This is probably them hitting the ice edge right here. Continued to feed on calves, and we think that killer whales may take 30% of calf production every year. So this is a really significant event. One other thing I want to at least mention is as the population has recovered, we have lots of whales. These whales are coastal migrators. They're migrating inshore. We also have more and more big, fast ships. And so we're having these sorts of things happen. They're hitting gray whales. They're probably the animal that gets hit the most. And it isn't just big cargo vessels going through. There's also cruise traffic going down the coast of Baja. And so we're seeing more and more interactions between gray whales and shipping traffic. And it's a significant event, and we're working on it. Okay, thank you very much for your attention. Dave is now going to talk a little bit about the Western Pacific animals.
My name is Dave Weller, and thank you. I'm in the Protected Resources Division at Southwest Fisheries Science Center along with Wayne. And a lot of my work over the past 15 or 20 years has been on gray whales, except over in the Western Pacific. And we work greatly at the individual level. We get to know individuals personally, actually. And we know a lot about the individuals. And rather than the population level, we're working at a smaller scale. I thought a lot about this talk, and normally I stick to the facts and the science, but behind this entire project is a personal story for a lot of us. There's a woman in the back here who I'll introduce in just a minute, who it's equally as personal for her as it is for me, because we really risk our lives and our well-being in order to try and do something for a population that's really struggling. So I decided tonight to actually share with you some of that personal element. It's a blend of research and results, but also the personal story. So gray whales in the North Pacific, Wayne just did a nice job for you of telling you where they are, but let me just go over it again for you. This is the Eastern North Pacific population. You'll see ENP throughout the talk as the abbreviation for Eastern North Pacific. This is where they're feeding during the summer. They migrate down the coastline here, and this is where they spend their winters. Now on the other side of the Pacific in the west, and that abbreviation will be WNP, this is the feeding area that we've spent so much time studying them. That's in the far east of Russia off of Sakhalin Island and the Okhotsk Sea. And the migration corridor for these guys historically was off the sides of Japan and along the Korean peninsula, but we don't actually know where that population goes in the wintertime. We've got some records from China and the South China Sea, but it still remains a mystery to this day as to where they go. Both populations were heavily hit by whaling. The eastern population, the eastern North Pacific population, has recovered about 20,000 individuals. The western population has not recovered, and I'm going to give you those numbers in just a minute. One thing to keep in mind is that the whaling that was done on the western population was off the Korean peninsula. They were in big numbers going by Korea, and I'm going to tell you this now as foreshadowing for what you're going to learn later. They were going by in big numbers, and it was actually Japanese whalers over there whaling along the Korean peninsula, but these fellows are actually Koreans, and they're dressed in their traditional Korean garb. This is pictures from 1900. So this is where most of the decline happened for the western population during that hunt. This guy in 1995, if any of you know Bob Brownell, he's a senior scientist in our lab, and his job is to follow international events and to follow international conservation issues for marine mammals. And he tracks those like a dog. He's incredible. The next thing on his agenda is X, Y, Z, and he just keeps going and going. But about 1995, he got pretty excited about western gray whales and that somebody needed to do something because we didn't know anything about them. We didn't even know if they were still in existence. So Bob posed the question, does anybody want to go to Sakhalin Island? Sure enough, out of this cast of characters, the two fellows with their arms crossed said, yeah, we'll go. And that's Rick LeDuc, and that's Bob Pittman, who Bob's somewhere in the audience in the back there. He's got a similar mustache, but not quite as radical as 1987. So those guys shot over there for a couple of weeks to do a feasibility test to let us know whether there are whales there. Can you get close to them? Can you actually study them in that part of Russia? They came back and they said, you bet, you can do it. So we took that advice from them, and we developed this long-term project that I'm going to tell you about right now. Let's just review our geography for a moment. That's Sakhalin Island. This is Japan. This is the coast of Korea down to China. It's all the way in the western Pacific. This is the far east of Russia. This is where our field site has been for the past 18 years. Here's what it looks like. It's called Sakhalin Island Piltoon Lagoon, and it's a giant lagoon system. It's 90 kilometers long, it's 15 kilometers wide, and it's got only a single entrance and exit. So all of the lagoon water pours through this channel, and all of the marine environment water comes into the channel. It's pretty significant. This is the source that's feeding the benthos that the whales are feeding on. The feeding area in that area for the gray whales is about 70 kilometers long and 5 kilometers wide. It's tiny. And the main ecological source that's feeding that environment is this lagoon. Now, our field site is right there, so our boat we would keep here, we'd go out through the mud bank around the corner and then out here, and we'd start to study the whales here. Unlike Baja, the whales don't come into the lagoon and use the lagoon. It's very shallow. It's got huge tide swings in it, so the whales are along this part of the coastline out here. Now, one thing you notice here is there are no roads there. It's completely remote. And we knew a little bit about that getting into it. And then we started to do some reading, and sure enough, this is what Chekhov had to say about it. So armed with his book, A Journey to Sakhalin, a bunch of us decided, let's go. The first thing we encountered is how to get over to the island, and that's on one of these Soviet-era Mi-8 Russian helicopters. Not in particularly good condition, and I remember showing Wayne a picture of this a few years ago, or 10 years ago, and he said, "Are you crazy?" When we got in the airplane, we had coordinates on how to go and where we wanted to go, and we tried to explain GPS, and the pilots were like, "No GPS." And we're like, "Well, what do we do?" And they're like, "No GPS." So we asked our Russian colleagues, how do we explain to them that we want to use their GPS system? And they said, they don't have any GPS. Right? So we used our own. But that was the initial awakening of what kind of journey this is going to be and how difficult it could actually get. This is the field site. This is Mayak Piltun, or the Piltun Lighthouse. It's a 1963 steel Soviet-era lighthouse. It's ready to fall down. This was our living quarters here. These are two radio relay towers. And again, there's no roads, there's no infrastructure, there's nobody around for 100 kilometers. There's nothing there. So once you get in, you're in, and once you go out, you're out. So it looks romantic, right? It looks kind of like, hey, this is a cool journey and expedition, and we're out in nature. And yeah, rustic luxury, I would call this. This is the field house. We had half of this house. We needed to rebuild most of it because the roof had caved in under snow. But look, we've got a few luxuries here. Twin outhouses, a super long clothes drying line, and a pile of coal. So we were doing okay, actually. It was not for everybody. It was a bit of a psychological experiment, actually. You take a bunch of Americans, a bunch of Russians, with whatever food they have for the season, put them in this little tiny isolated outpost and see how they do. It's like reality TV. But we did well, actually. We didn't have electricity. We used a generator to charge things at night. So we needed to heat the house with firewood that we found and cut and chopped, and to cook all of our meals on that. We had a well, which we monitored every day to make sure that the water level was okay, and also there were unexpected animals frequently floating within our well water. Thus the expression on our faces. We lived for good weather. The weather there is difficult, it's challenging. So we lived for good weather days like this. There's the sunrise over the ocean in the morning. It allowed us to get our boat into the water and to get out there and to meet these whales and to learn something about them. We dreaded the bad weather. This is the 1st of September, the first snow. This was very early on, the second year that we were there, and what we learned is that cold comes so early there, there's no extended summer. The outboards were freezing. The remaining water inside the outboards were freezing solid, so every night we needed to drag the boats up from the lagoon, take the engines off, bring them into the cabin, keep them warm, put them on the next morning, go back out. It was quite a challenge. Fog, however, was the arch enemy of all time. 27 days in a row was the record that we were not able to work. The fog is so thick, it just sits on you. You can't really see much further than the black curtain. In fact, it looks a lot like that black curtain, which didn't allow us to navigate, to find whales, to do the very work that we were there to do. I would say in most years we were lucky if we were able to work on the water 30% of the time. So a lot of sitting around. And I often related it to a hostage crisis. All of these students and people there to do science were feeling pretty pent up. And in fact, this very famous novel, number 18, was written about the hostage crisis in Sakhalin Island. However, we did relish the good times. Beautiful, isolated, remote, desolate, silent, sunsets, black nights, stars everywhere. It was an incredible place to be, although nerve-wracking. We were out in the middle of nowhere. We really didn't have the infrastructure to rescue us or to pick us up quickly and get us out. We almost lost my beloved PhD advisor, Bernd Wurzig. We had a party for him when he arrived. We collected wild mushrooms. The Russian students knew which ones to collect. We cooked them, we ate them, and Bernd, sure enough, went downhill very quickly. with mushroom poisoning. Fortunately, he survived, and I did get my PhD under him. But heck, it took us 8 hours just to get a helicopter to the camp in order to take him up to a hospital. So we were pretty far out there. And I do have to say, however, that it was a life-changing experience, I think, for every single person that made the effort to get over there. All right, so let's get back to the facts. This is what we know about western gray whales in the western North Pacific. Here's our study site. We know they're there every summer to feed. We have a few scattered records of gray whales being up here. We know that about 50 or 60 gray whales are over here, and we've matched those to our feeding areas. So we know there's some interchange here during the summer, some feeding here early. They seem to mostly come over here by the end of the summer. Down here, it becomes much more of a mystery. This area, we have a few records from Japan in the past 20 or 25 years. And over here in China, we've got very few, just a handful of records since the 1930s. And I'm going to tell you more about those in just a moment. One thing that is striking is this, the Korean Peninsula. Remember I told you that's where the whales were whaled because they were in such big numbers? The Koreans have been doing a terrific job of looking for gray whales over the past 12 years in that part of the world. And what they found, they're there when the whales should be migrating through. They're there looking for whales when they were hunted. Zero. So it's our hypothesis that this coastline has been abandoned as a migration corridor by gray whales in the western North Pacific. That's one thing that looking at human-related threats can tell us about. They were hammered and hit so hard right here that I think now they've completely abandoned the area and they're no longer passing through there. They're now using this part of the migration corridor on either side of Japan. So the bread and butter of our research program has been photo identification. All gray whales can be identified by taking a photograph of their side or their flukes. Even calves. We've been following some animals now for 18 years, from the time they were born all the way until most recently this year. We also collect small biopsy samples. We shoot a dart at the side of the whale. We take a little piece of blubber and skin that's about the size of a pencil eraser. And we can do all kinds of crazy cool stuff with those. And I'm going to tell you a little bit more about that in just a moment. So I'm just going to take you through this table quickly. I don't want you to look at it all, but it does show you how much effort we've put into this study. And I'm going to shoot you right down to this row that's highlighted in green. We've spent 384 days on the water, 780 hours of direct observation that's in the company of these whales. We've encountered over 3,000 groups, and we've identified 199 individuals. Now remember that that's how many we've identified. Not all of them are still alive. Okay, the study's long enough now that we've experienced some mortality. In terms of the annual sighting patterns, this is kind of interesting because it starts to tie in with Wayne's talk. Here's the number of new non-calves we get on an annual basis. So you can see the past 5 or 6 years, almost all of the whales that we encounter there and take photographs are old friends. We've already known them from past years. That's reflected over here in this resighting percentage. This is incredibly high. So the fidelity to the area is very high. It's the same whales coming back year after year after year. That includes reproductive females, and that's kind of a key to understanding what's going on with the population. Now what Wayne showed you and what I'm going to show you at a much smaller scale is the same variation in the number of calves that are born on an annual basis. It's bouncing around. It's just not the peaks and valleys that are so dramatic when you've got 20,000 or so individuals. So very few calves are born, and most of that catalog of 200 or so has to do with the addition of new calves, not the addition of unrecognized adults. Research on genetics, this is kind of where some aspects of the movement between the Eastern and Western Pacific starts to come to light. So we've taken, at this time, I think this is through 2007, 95 to 2007, we collected 142 biopsy samples from the individuals that we'd photo identified. So about 83% of the population at that time. There is an overall male bias, 58% male, 42% female. Of course, we'd like to see more females than males for a population to thrive. That's not what we see, and it's especially notable in the calves. So of all the calves that are born, we also sampled them. We get the sex determination, and 66% of the calves are males. There is significant mitochondrial and nuclear genetic differences between the western and eastern North Pacific populations, and that's work that's been done by Amy Lang. Now, Amy, could you raise your hand back there and just let everybody see who you are? Because I talk about you a lot in the next few slides. Now, the Kremlin at some point in 2010 got interested in our biopsy sampling program, and they sent their ace marksman, Vlad, over to try his hand at it. And this is what he said to the press after his day on the boat. I had this sporting feeling. So he took 4 shots and he only got 1 sample. It's a pretty bad batting average. And at the risk of never getting a visa to go back to Russia again, I have some advice for Vlad, is don't try and shoot a biopsy from the bow of a boat that's bouncing along like that, right? The crossbow is just going up and down and up and down and up and down. So it's pretty funny. You probably know that President Putin has done all of these grandiose expeditions to kind of show his presidential might, if you will, and most recently flying with cranes in a hang glider just last week. So anyway, we experienced that same thing right there in our little field site. Conservation concerns. In 2000, the population was listed by the International Union for Conservation of Nature as it's critically endangered. It means there's a high probability that the population will be extinct in the near future. The current population parameters is estimated by our friend Justin Cook. The population is hovering at about 130 individuals. It's a very slow increase, about 3% increase in the population size over the past 10 years. And there's more or less 30 reproductive females in the population. There's a big number of human-related threats to the population. This is Sakhalin Island. This is the feeding area, and all of these boxes with the word Sakhalin and numbered are offshore oil and gas developments. So we've watched from the early years when there was no oil and gas development now to 4 platforms being in place, pipeline, the whole infrastructure. These 2 giant projects right off the feeding ground are Shell and Exxon. So we've watched all of that. We've tried to work with them to develop monitoring and mitigation programs. But it is a concern. You can see anywhere around the island and anywhere on the feeding area has got the potential for threat to the population. The other thing that may be more important than that is actually these net entanglements in Japan. Between 2005 and 2007, 4 female, of course female and not males, which is really a shame, were unintentionally drowned in Japanese set nets. It's a real problem. 4 females taken from this population in the matter of a couple of years is unsustainable. We've done the modeling on it, and within 40 years the population will be gone if that level of mortality continues. To Japan's merit, they have done a lot to try and remedy the situation. We've worked with them closely. The IWC has worked with them, the IUCN. And in the past, by-caught whales could be sold to the market for profit. Gray whales are now off that list. So if you accidentally catch a gray whale in your net, you cannot sell it, which is great because there is a thing that we worry about called intentional bycatch, in which fishermen may be helping whales go into their nets so they can be by-caught. But that's off the board now, so that's a huge step in the right direction. Now let me take you over here to the kind of the meat of the talk, the movements between the western North Pacific and the eastern North Pacific. Some of this may have to do with climate change, with the ice. Wayne showed you that picture of the ice this year, way down to the south, and how a whale would block right up against it. You know, that ice was coming way down to here. And so if a whale were coming up here and bumped into the ice, it might be that they just follow the ice right along and come over somewhere else, right? So I'm going to talk about this. It's new. It's relatively exciting. And the person that helped us understand this at the very beginning is Dr. Amy Lang, formerly known as Amy Lang when she was my graduate student, right here at Scripps. But now she's Dr. Amy Lang, and she's right down the hall from me, which I'm thrilled about. I've known her since she was an intern. But Amy was working on her PhD at the time, comparing the eastern and the western genetics between the 2 populations. Pretty straightforward, easy study, right? We've got a great sample here, and she had a great sample here. One day Amy came down to my office and she said, Dave, you never believe what? And I thought, okay, what? She's getting married, she's going to move, she decided not to finish her PhD. And she said, I think I found some genetic matches between the West and the East, right? I think there are whales here that match genetically, genotyped as a match to the other side. I thought, no way, we messed up the samples, or there's some lab error or something like that. But in fact, she was right. So she made 2 matches back in 2005. Yeah, so she made 2 matches. The samples were from 1995, but sure enough, 1 male and 1 female. She reported it in her PhD, and she made the first matches from the Western Pacific to the Eastern Pacific. Way to go, Amy, I was wrong. So based upon the work of Amy and a recent satellite tagging program that also showed one whale coming across the Pacific this way. That whale's name was Flex. You may have followed him on Facebook. We decided, seriously, he's got a Facebook page. We decided it was time to undertake a more comprehensive comparison between the Eastern and the Western Pacific and to look at population mixing. So the way we did that is we took our photographic catalog and we compared it to a photographic catalog that has been amassed over here by Cascadia Research Collective. This catalog is about 1,200 individuals. It's mostly of the Pacific Coast feeding group, those summer residents that Wayne talked about. But it's also a lot of whales that are just migrating by the coast. And we thought, well, the first try is to match this catalog to that one. We did that. It's been completed. We've got a paper in press on it, and these are the results. Sure enough, we started to find some more matches. So 3 males, 2 females, and 1 unknown sex. These are the individuals that match between the 2 areas, and the most interesting stuff are kind of these footnotes about them. All the matches were to a single point on the coast at southern Vancouver Island. 3 of those whales were in the same group together, and 3 of them were in 2 groups on the same day but slightly separated. It's the first inkling we have that whales may be staying together as they're migrating across the Pacific. We had no idea, we still don't have any idea about that for baleen whales, about that kind of cohesion of groups. But this is actually pretty phenomenal. If we find more matches and we find more of that, it tells us something about these whales that we've never known before. 3 of the 6 matches were first identified as calves over in Russia. All the whales sighted off Sakhalin prior to Vancouver Island. 5 of them were sighted back in Sakhalin after Vancouver Island. And 4 of the 6 were sighted in the Eastern Pacific and the Western Pacific in the same year. They're moving back and forth. At least some of the whales are moving back and forth. Is this new? We don't know. Is it climate related? We don't know. But it's exciting. It's something that we'd never expected. Now let me introduce you to Dr. Amanda Bradford, formerly known as Amanda Bradford when she was my graduate student at University of Washington. This is a lot of fun for me because I also knew Amanda when she was an intern. So these are like my children. My 2 children are right here, but they're like my other children, Amy and Amanda. Amanda has this uncanny ability to know all of the whales in our catalog by sight. She's just like, well, there's Vivara, there's Flex, there's Pirate, you know, she knows them all. And I said, you know, Amanda, you should look at the online catalogs from Mexico sometime and just see what you see. So sure enough, I got a call from Amanda. I was like, Dave, you never believe what? And I was like, no, she's not getting married. She's not. She's found something, right? I learned a lesson from Amy. And within minutes of just kind of casually flipping through whales that were identified in Baja, she found some matches to our catalog up off of Russia, right? So Amanda, within minutes, it was literally 30 minutes of just kind of trying to do it opportunistically. 2 males and 2 females, different from the whales from Vancouver Island. We followed this study up with our colleague Jorge Urban. He's from Mexico. He's a Mexican researcher, works in the lagoons. He maintains and owns those Mexican catalogs. And now working together with Jorge and his students, we've bumped that up to 12 matches between Mexico and Russia. These are the 4 animals that Amanda made the matches to. Again, one of them was a calf, first identified off of Russia. It was also photo matched off the Commander Islands. One of these animals, number 42, was identified as a mother in Mexico, but has never been identified as a mother in Russia. That's pretty key to our understanding about reproductive output. Are we missing some of them? Are some of the calves disappearing before the moms ever get back over to the other side? One of the whales was a putative father. This is from Amy's work. And then one of them, identified as a mother in Laguna San Ignacio, was also a known mother over in Russia. So the puzzle, we thought we had the puzzle pretty much assembled and put together. It's come apart a little bit. But to me, this is fascinating. It's kind of a rebirth of the project and some momentum to get reinvigorated about it. Overall, we've now got 22 matches. When you combine everything together, the genetics and the photo ID, satellite telemetry, we've got 22 animals that have been known to move from Russia, either here to the Pacific Northwest, California, or Mexico. Now, as you know, it's got a lot of us thinking, right? Especially me. The story's not over, though. And this is where our focus is now shifting, is that we've got whales being caught in nets off the coast of Japan. This is January 2007. This whale was caught in a net. It was a 1-year-old female who we knew from Russia. Okay? January. Those whales that are coming across the Pacific are coming across in January. She obviously went a different direction. Here's a whale in China just from last year, a female. Again, why are they all females? I don't know. Maybe they're more coastal in their habits, but it's a shame that that happens to be the case. A fisheries interaction off of China in November 2011. That's when whales are starting to go across the Pacific from the west over to the east. She obviously was way far south within the western North Pacific at the same time of year. Of the 13 records of gray whales from Japan since 1990, most have been reported during March and May, in that period. That's when all of our matches have been made to the eastern North Pacific. So it's pretty clear, based upon a few records, that whales from the western North Pacific are going 2 different directions. Some are coming over to the east, some are going down south and staying in the western North Pacific. What does that mean? I'll take you right down to this conclusion, which is the most puzzling, is that it's possible that the number of whales in the western North Pacific is smaller than we've previously estimated. It's actually a worse situation than we had anticipated. It was already bad. The reason I say that is because all of our modeling and our abundance estimates have been done on every whale seen off of Sakhalin Island. We come up with an abundance estimate of 130. But some of those whales are likely to belong to the eastern North Pacific population, and they're not true western North Pacific animals. But in our analysis, we've bundled them all together. So if we were able to take that apart and do an abundance estimate on true western North Pacific whales, it could be substantially smaller than we've estimated. And that's a real problem. That makes the situation that much more important to follow on. I would just direct you to this website if you have an interest. The IUCN has got a panel set up on the conservation of western North Pacific gray whales. That's the website for this range-wide conservation plan. And in closing, I'd just like to say thanks to a number of people and funding agencies. And I'd like to say thanks to Maggie, my daughter, and Henry, my son, and my wife, Sarah, for being here tonight. Thanks very much.